We want to be able to graph these two functions, find the area of intersection, and we'll do it by hand first, and then we'll put it on this this plotting tool. I think for me, and maybe for some of you, it's easier to do this by hand than to actually try to figure out what's going on here with this this object properties. But we'll walk through it, and hopefully, if I get it right, you'll see this video. So first, we want to be able to solve the point of intersection for these two graphs. Graph these two functions. Find that the region where they are intersecting and bounded, and then be able to integrate and find the area. The purpose of this video is not so much to calculate the integral to find the area, but to show you how this graphing tool works with WebAssign. But I will first go ahead and see if we can walk through and try to solve this problem. F of x is equal to negative x squared plus 6x plus 5. That was the first one. So what I'm going to do is find the vertex, the x-intercepts, and then take the second function, find its intercepts, and then find the points of intersection, and then graph both of these two graphs. So to find the vertex, do this a couple ways. Take the first derivative and be done with it, or you can go through the process of completing the square. I'm going to complete the square because after I find the vertex by completing the square, I could easily find the x-intercepts. I'm going to factor out a negative from the first two parts. Negative. And then, in completing the square, we take half of the coefficient of x. Negative 6 divided by 2 is negative 3. Then we're going to square it. We get 9. We're going to add 9 and subtract 9. So we have not hurt offset the problem. Take the negative part out at negative 9. This is negative x squared minus 6x plus 9. The negative part comes out. It's negative times that negative there. It comes out the front door, and it has to recognize the porter. So this is plus 9 plus 5. So here f of x is equal to negative. You could factor this as x minus 3 to be squared plus 14. So my vertex is at 3 comma 14 for the vertex. Now I can find the x-intercepts by setting this function equal to 0. Now I do this way because I cannot factor this guy directly. We get irrational terms. So you subtract 14 on both sides and then divide both sides by negative, and that gives us x minus 3 to be squared is equal to 14. Take the square root of both sides. So we get x minus 3 is equal to plus or minus the square root of 14. So x is equal to 3 plus the square root of 14. And on a graphing, just not a graphing, but a regular scientific calculator or just a simple calculator. Well, a calculator that has radicals. You get estimation of 6.74. In the second term, we get 3 minus the square root of 14, somewhat close to negative 0.74. So these are all good points that we'll need in graphing. So for that second equation, g of x is equal to x plus 5. Straightforward there. If x is 0, y is 5, and if y is 0, that is g is 0, then x has to be negative 5. So these are our here x and y intercepts. Okay. So we have that. So the next thing we need to know is to find the possible points of intersection. So we set the two equations equal. Negative x squared plus 6x plus 5 is equal to x plus 5. We solve, so we get negative x squared plus 5x equal to 0. We factor out a negative x. We have left x minus 5 equal to 0. That implies x equal to 0, x equal to 5. This is points of intersection. So here, when x is equal to 0, then y is 5. That's for both equations. So here we get 0, 5. And then when x is equal to 5, we get y is equal to 10. Again, these are our points of intersection. Now, we can graph. Let's say this is 5, 10, 5, 10, 15, negative 5. Just do negative 10 for consistency. So if we take that parabola, it had a vertex of 3, 14. Do that in purple. So 3, 14. Say that's the top value, and then the it has an intercept. You remember? Well, maybe you don't remember, but if we take this guy and let f equal to 0, we get, well, let x equal to 0. Excuse me. We get f is equal to 5. And it's a common point of intersection anyway, and we get it there as well. So 0, 5. So this parabola has a touchdown there. The parabola does touch down at 5, 10. It's going to be a common point of intersection for both of these graphs. The so-called x-intercepts is a little bit close to 7 right here. So you kind of dot it through. And then this one over here is a little bit close to -1. So about right there. And if your graphing skills are better than mine, then whoopee-doo. I'll try to get it right. Okay. On that graphing tool for the computer, by all means, you can make it look really nice. Now that line is 0, 5, -5, 0, and then also that point there. So which tells us that my scale for -5 is off. It's not good. Blue. So you get that. Now the region that's bounded is this region in here. We got to make sure we have our points right for the graph. So this is 5, 10 at point of intersection. And this point of intersection there, 0, 5. Then we have the vertex, 3, 14. So Let's graph first, and then we'll do the solving that they asked us to do. So select an object tool. So let's say first we're going to do the parabola. And the parabola, we know we had a vertex of 3, 14. So it's there. And then we know that it had an intercept at 0, 5. Right? So I think I lost my graph. So that was 1. And then we're at 0, 5. And that looks right in terms of that intercept being close to 7 and then close to -1. And then for the other graph, and I think it was something about this guy where I don't think they liked the plotting that I'm doing. I think they wanted you to put the points in. And so maybe I'll do that as well, just to be accurate, because I've done this with the just graphing like this, and it said I was wrong. Then I went back and put the same points down there and let the machine do the graphing for me, and it said it was right. So it seems like it doesn't like the way we graph. So here, that line, you had a point at 0, 5. Then you had a point over in the negative, and since my scale doesn't want to go over there, I guess it picks it up. Well, we can go to, we had another one at 5, 10. So I'll just go there. Okay. And then they want us to do a solid. We're going to do our solid. I think we can do that. Shade the region in, right? So we're going to fill that area in there. Okay. So we have that. So now we're going to move down to solve for the region. So we'll go back to our paper and we'll finish this problem. So the region is bounded, this green area, from 0 to 5 based on the points of intersection. So we have 0 less than x less than 5. Now the graphs, the above graph, if you notice here, that f of x is above, and then this was g, then g is below. And so there we can get our so-called bound for y, if you will, that y is bounded here below by this x plus 5, and then bounded above, and this y represents the graph, the shaded region, bounded above by that negative x squared plus 6x plus 5. Call that our so-called region. And what we want to do is to be able to graph. So x is bounded from 0 to 5. If this was like in calculus 3, you would have, you're looking for the area, you would have x going from 0 to 5, and then you have y going from x plus 5 to negative x squared plus 6x plus 5. This would be dy and then dx. See, the y's are here with this integral. Then on the outside is the dx. Now, but in calculus 1, if you just want to look at that, how it's introduced in calculus 1, the area here goes from 0 to 5 for the bounded region for x. But then we say that whatever the top function is, it's going to be that f of x. Then it's going to be minus the g of x. This is exactly the integral from x plus 5 to negative x squared plus 6x plus 5 with respect to y. And then we just say this is dx. So this is calculus 2, or calculus 3, I should say. We're doing the same thing. And then our calculus 1. So we have the integral from 0 to 5. F of x was that parabola, negative x squared plus 6x plus 5 minus g of x, that's parentheses x plus 5 dx. So this is the integral from 0 to 5, negative x squared plus 6x minus x is just plus 5x. Then 5 minus 5 cancels out. It's just dx. Now we do not hesitate. We integrate. So this is negative x to the third. Well, this is calculus 2. I'm sorry, I didn't mean to underrate you all. Please forgive me. Oh, boy. When you're teaching calculus 1, 2, and 3 at the same time, you kind of get things mixed up. Plus 5x squared all over 2. That's bounded here, evaluated from 0 to 5. So we get negative 125 over 3 plus 25 times 5 is 125 all over 2. And so we get these common denominators 6, 3 goes in 6 2 times, gives us a negative 250 plus 2 goes into 6 3 times at 125, 375. And so we end up with 125 over 6. So take that for our bounded area. We go back and plug that in, 125 divided by 6. I think that's right, but I want to make sure we got that graph right up there, right? So submit our answer. Let's see what it says. So it's see how this guy it doesn't like for some reason when you select the graphs over here, they want you to do, for whatever strange reason it is, they like you to do that object property. So I just did that to show you that I've done this before, and this is what happened. And students have done that, and they've gotten it wrong. But you contact me and let me know what problem it is. I'll give you credit because it's right. But for some strange reason, WebAssign is weird that they want you to use this object property. So we're going to use that and just say clear. Do you want to clear the graph? It will delete all. That's fine. So we'll just start over. So let's get the straight line first. So here we got 0, comma 5. That was 1 point. And then we also had 5, comma 10. Oops. That was the other point. So now we go to the parabola shape, and the vertex we got to be 3, comma 14. And then another point that we can select would be 0, comma 5. Right. And then you want to shade in this region here. We're going to say fill, and it says where? It says right there. So now submit the answer. And it says we're right. Where's the problem? So you see that? Now it says it's right. We did the same thing, right? So again, just use that object properties just to satisfy these jerks. I mean, these computer analysts. And yes, and that should do it. Well, hope I didn't take that long, but I spent time on just the hard part, just working the problem, and then showing you that work does take place on paper still. Then you transfer that to the computer. I want to show you this glitch as well with the graphing, where when you go in and you use the tools over here and you plot the graph and you get it right, and then it tells you you're wrong, just use the object properties and just pick whatever shape that you need. Okay? So hopefully that'll do it. Thank you. Go well.